as the top of the tree seen on the top right of the slide. We learned about signs and symptoms of disease and how they relate to organ systems. And we learned about all of the specialties in medicine, whether they be cardiology, pulmonology, urology, immunology, etc. That was all excellent and important information. And that information allowed us to practice excellent organ-based medicine and make an organ-based diagnosis. Modern medicine provides us excellent tools and offers the descriptive knowledge we need to address symptoms and their effects. But what makes functional medicine different, the value add, if you will, is that we use all of what we learned in medical school to make organ-based diagnosis, but we add what we like to consider the trunk and roots of the tree. I will blow this up in a minute or two to show you what that means. We call this 21st century medicine, which is a systems-based medicine. And in addition to the great descriptive medicine that we learned in our training, systems-based medicine provides an explanation of underlying mechanisms and root causes of disease. So we don't just suppress symptoms and effects, but we address their underlying root causes. The way this looks on our functional medicine tree is that we have two iconic tools known as the timeline and the matrix, popping up on the left and right of the tree. And you don't have to know anything about them in detail right now, but just so you know that in the way that we take a history using the patient's entire life, it becomes a very personalized and precise approach according to what the physiological influences of their life had given them in terms of their current dysfunctions and diseases, and how to use our matrix to organize clinical information. This makes our approach very preventive, predictive, and participatory. If we look at the base of the tree to see the special features of functional medicine and how they would relate to our approach to both acute COVID mitigation and vaccination preparation, this is what it would look like. The largest rectangle at the top shows the 7 key physiological functions. Assimilation refers primarily to what we take into the body through the gut. Defense and repair refers to the immune system. Energy refers to mitochondrial function, which is also linked to immune function. The way that we handle toxins through biotransformation and elimination is important, as is hormone balance. Transport functions to move things in the body from one place to another, and all of the barriers and structures in the body comprise structural integrity that protect and allow the immune system to function optimally. In the next rectangle, you see the terms antecedents, triggers, and mediators. And we use these terms to know what predisposes, what activates, and what perpetuates dysfunction and symptoms, and that allows us to keep central focus at the roots of the tree. Mental, emotional, and spiritual influences, as well as the lifestyle factors of sleep, exercise, nutrition, stress, and relationships. This is the value add of functional medicine. And you'll be able to see all of this detailed in our 3R course. I'm just going to drive through these next few slides quickly to show you how we address the comorbidities seen in the official list from the CDC. We don't just address these diseases with pharmaceuticals. We identify their underlying causes and reverse them by addressing the key physiologic dysfunctions of mitochondrial dysfunction, oxidative stress, hyperglycemia, inflammation, and immune system function. We believe that these functional imbalances are underemphasized in the current conventional approach to COVID-19, but we emphasize them, and they're incredibly important in our functional medicine module. We address these lifestyle factors in great detail and with great success in our model because, as I will show you later in this webinar, they're so vitally important, both in COVID-19, but also in optimal preparation for vaccination. This is our hypothesis for our entire approach to COVID. We believe that improving biochemical imbalances and lifestyle factors, especially those that I just mentioned, have biologic plausibility to favorably modulate the effectiveness of vaccines and the severity of their side effects, as well as mitigate acute COVID-19. More of this to come later in this webinar. Thank you.
Thank you, Dr. Evans. And indeed, Dr. Evans will return later this evening, and he will present a pre-vaccination protocol whereby you can help your patients while they are waiting for a vaccination to optimize their response to that vaccine. He will also be presenting an update to the online course based on a new agent that was approved within the last month. Next, we turn with pleasure to Dr. Patrick Hanaway to take a deep dive into the clinical conundrums surrounding the COVID vaccines. Please welcome Dr. Patrick Hanaway.
Thank you so much, Robert. Thank you so much. What I'm going to be doing over the next few minutes is laying out a dashboard of information that we've put together that looks at the features, concerns, and risks around the various vaccines that are available. Everything that's in phase 3 clinical trial or has received emergency use authorization by the FDA. So we're looking at the specific vaccines and talking about their efficacy and talking about the vaccine type that is present there, looking at what the research and clinical status is of the implementation of those vaccines, both in the United States and abroad. We'll have references to all of the trials and publications that are there. We'll talk about what ingredients are in each of them, the adjuvants or activators of the immune system that are there, issues of distribution, storage, and stability, talking about the levels of evidence and looking at efficacy, and also looking at what activates, as Dr. Zwicky will talk about, both B cell antibody function, but also T cell and cell-mediated immune function to be able to determine how effective is this vaccine at working. We'll talk a little bit about the variants that are there. We'll have more information in the Q&A session. Now, and we'll also talk about where the potential harms are. There are concerns that many of you have, short-term risk and long-term risk, and there are much of that is unknown at this point in time, and we'll be clear about what we know and what we don't know. We will work to continue to update the specific dashboard that we have, and this will be available to you as of this time. It's live now, and will be live and will be updated on a regular basis. If you go to ifm.org/COVID-19, as you see on the URL up at the top, and click on the vaccine tab. And once you're there, what you'll find is the dashboard. And so the dashboard at this point in time is 3 pages long and looks at the various different kinds of vaccines that are available. I'm going to focus in the next few minutes on talking about the Pfizer-BioNTech vaccine as well as the Johnson & Johnson vaccine, because these are 2 different vaccines. One is an mRNA type of vaccine. The other is a viral vector vaccine using the adenovirus. As you may know, the Pfizer and the Moderna vaccines, which are quite similar in their efficacy, have received emergency use authorization by the FDA. The Johnson & Johnson will be going before the FDA on February 26th, and it is expected from the data we've seen so far produced by the company. Notice the gray box here and here. The data we have on the Johnson & Johnson vaccine has not yet been peer-reviewed in the larger trials, but has been put out by the company. So we don't have as much information. For instance, we don't have the listing of what the ingredients are that are on there at this point in time for the Johnson & Johnson vaccine. Let me first speak to the vaccine types, and Dr. Zwicky will speak a little bit more about this, but there are vaccine types of the mRNA vaccine, which is a new technology, and people are concerned about it, but it's been demonstrated in the clinical trials to have quite a high efficacy. That is, its ability, as we see here, to be able to prevent recurrent illness. So in comparing those people who've received the vaccine versus not receiving the vaccine, we've seen that in the case of the Pfizer vaccine, 95% of those patients who receive the vaccine do not get COVID, as defined by a positive PCR test on follow-up. Now, interestingly here, because the data is ever changing, earlier it was noted that after the first vaccine that you receive, after the first dose, it's 52% effective, although more recent data indicates that by the time you have the repeat vaccine at 21 days, the efficacy is between 80 to 90%. And then we see the real-world data from Israel suggesting not only this 90% rate, but a 95%. And the term we use there is effectiveness. Efficacy is in a clinical trial. Effectiveness is what happens in the real world. Now, we'll compare this with other vaccines, such as the Johnson & Johnson vaccine, which instead of using mRNA, which is injected, the jab, as they say, and then goes into the cell, it's captured by the macrophages, goes into the cell, and the body's own production system uses it without it going into the nucleus and produces the protein, the so-called spike protein, that then is mounted on the cell, and the immune system creates antibodies to it. It also creates a T cell response to it, and that is the immune benefit. As we'll hear, it's not only the antibody effect, but it's also the T cell effect that makes a difference. With the Johnson & Johnson vaccine, and this uses a different modality. It uses a virus, an adenovirus, which is a common cold virus that it's inserted. The DNA is modified in that virus so that it goes into the cell, into the nucleus, and produces then again the mRNA in order to be able to produce the spike protein, as we see with the mRNA vaccine as well. Now, this type of vaccine has been used before in dengue fever, in Ebola, and some other infectious diseases, and is one that we're looking forward to seeing the data. Other viral vector vaccines that are out there include the AstraZeneca vaccine, which has been approved in the UK, and the Sputnik V vaccine, which has been approved in Russia and in other countries as well, where we see some pretty good data coming from there. This is differentiated from the Novavax vaccine that we see down here, which is a more classic purified protein, which actually uses an adjuvant, an irritant to the immune system in order to get the immune system to activate. Now, with the viral vector vaccines, because it's a live virus, and it's not an attenuated virus, it's a live virus, but it's not the coronavirus, the SARS-CoV-2, it is, as I said, an adenovirus. It does not use a specific adjuvant. It couldn't. It would affect the virus. Likewise, there's no specific adjuvant in the mRNA cells. They are basically preserved and kept stable, not by adjuvants, but by the cold temperatures that they have to maintain. Although there are some concerns around the polyethylene glycol leading to some anaphylactoid reactions. So here we see the evidence, and Dr. Zwicky will talk more about B cell activity and T cell activity that we see elevated in both the Pfizer and in the Johnson & Johnson vaccine. The efficacy in the Johnson & Johnson vaccine is overall about 72% versus 95% in the Pfizer vaccine. But as we can see, it's highly effective against preventing moderate to severe COVID, as well as preventing hospitalizations and preventing death in the original trials that are presented from the J&J website data. We'll see the peer-reviewed data in a couple of weeks, and we'll talk about it more when we meet again on March 16th. The variants now, we're seeing variants that are rising, the so-called B1.1.7, which is from the UK, and the B1.3.51, which is from South Africa. There are other variants, one from Brazil and one from California, that we do not yet have any specific data on in terms of efficacy. We see that the efficacy of the adenovirus is not as great against the South African virus, but that's just measuring the antibodies. We need to measure the overall immune response as well, which Dr. Zwicky will be talking about other ways to be able to do that. When we talk about the possibility of adverse effects, there have been an anaphylactic reaction that's been noted, and that's in approximately 1 in 100,000 people will have that. That's both to the Pfizer vaccine and the Moderna vaccine. There's also a Bell's palsy that has been noted, and in the Johnson & Johnson, we see fever and fatigue and arthralgias and myalgias that go on. Now, there's a lot of questions that we don't know the answer to. And so when we look at something like the Pfizer BioNTech vaccine, can it cause autoimmunity? Over 50 questions that we received out of the 300 were questions about autoimmune disease. And if you have that, who should get the vaccine? What are the risks? And we'll be talking about that in our Q&A section. Our concern is that people who have uncontrolled autoimmune disease may have some greater risk profile associated with the vaccine, but they also will have a greater risk profile if they get the SARS-CoV-2 wild type infection going on. Pregnancy, there's controversy about that. We'll talk about that controversy with Dr. Evans as an OBGYN answering those questions. There's also, as I said, the question, an absolute contraindication is if you've had an anaphylactic reaction to the vaccine, or relative contraindication if you've had a reaction in the past, an anaphylactic reaction to polysorbate 80 or the polyethylene glycol. But there's still many unknowns, and we call them the known unknowns. They're questions that we're asking but have not been yet resolved in the peer-reviewed literature. Now, this is true not only for the mRNA vaccines, but it's also true for the adenovirus vaccines, and clearly is true for the purified protein vaccine, for which we do not have more information. So this dashboard is going to be available to you, is going to be updated on a regular basis to give you really good curated information that we can use to be able to look at. Everything that we see here is referenced, as you'll see in the slides, and you can click on that on the website, and it will take you to the papers that are available. Almost all of the papers around COVID-19 are available for free. This is something that the scientific and medical community has made available to allow for rapid research and understanding of what's going on. So again, you can go to the ifm.org/COVID-19 URL and be able to click on that and click on the vaccine tab right here to have access into IFM's vaccine statement, as well as to the dashboard that we have here, the indication of how was I going to say this? The future doses and things that we talk about in terms of our pre-vaccination protocol of what to do to prepare for that will also be available. We'll hear Dr. Evans talking about that in a little bit. So we look forward to your questions and really appreciate you being here. Thank you.
Thank you, Dr. Hanaway. And yes, if you would like to submit more questions, hover your cursor down at the bottom of the screen at the Q&A box. Next, we have Dr. Heather Zwicky, where you will want to watch for, yes, there are ways that you can improve function, and that's the basis of functional medicine. You can improve your physiological function to have an optimal response to vaccines, and the response to a vaccination is not just about antibody response. So with great pleasure, we will present our subject matter expert, Dr. Heather Zwicky. Dr. Zwicky?
Thanks for the handoff, Drs. Hanaway and Luby. Next slide, please. So now that we've seen some of the details around these vaccines, let's discuss some of the fears that...
We always have to be concerned about those who have a mild case being able to infect others, and they may not have large symptoms, but others near them might be more vulnerable to have a worse case. And as you mentioned, herd immunity is the goal. We're trying to decrease the likelihood of that type of community spread. We also cannot predict who of low risk, what we would look at as low risk, might have a severe infection. And that includes from pediatric all the way through to adults. And we have many adults who are physically fit and don't consider themselves to be at high risk, who have long-term effects from having COVID-19 infection.
And so as we talk about that, Dr. Evans, as an OBGYN, a number of people have raised questions about pregnancy, about infertility issues. Can I get the vaccine if I'm pregnant? How long, if I get the vaccine, how long should I wait before I get pregnant?
So this absolutely is a huge question. And unfortunately, we really can't use a lot of data to guide us with an answer, because there's absolutely no data on the use of these vaccines in pregnancy. And even though that's the case, ACOG, the American College of OBGYN, and SMFM, Society of Maternal Fetal Medicine, have very strong statements that say the vaccine should not be withheld and that a discussion with the patient should be held. Now, the World Health Organization, however, has a different recommendation, which says that the vaccine should be withheld unless the patient has a high risk of exposure. And so it's very difficult for a woman who's pregnant or thinking about getting pregnant to decide what to do when there's no data and there's conflicting information from the professional societies. So what we have to do is look at what we do know. And so what we do know is that in animal studies, there's no toxicity. We know that women that are pregnant, if they do contract COVID-19, they have a much higher risk of severe illness and a much higher risk of death. So this sort of tells us that we always have to be, when we look at the extremes, which is if you get it, if you're likely to get it, if you're out there, if you're not able to safely isolate, if you're a frontline worker, it really can make a difference with your risk of death. And so that's why it's important to individualize. Women have to decide what their own risks are, what their risk tolerances are, and then make the decision. Are they going to wait until after they deliver, or maybe wait for a more traditional vaccine if they are pregnant? As far as the fertility question goes, this does not impact fertility in any way for men or for women.
Dr. Zwicky, could you just elaborate on that for a moment? There's been a concern raised that there's a component within the mRNA that it correlates with the syncytium that is a part of the trophoblast in the placenta, and that's raised a concern among some people that even though there is no evidence, as Dr. Evans just said, that there may be some untoward risk.
Yeah, there's been several videos that have gone out. There is no data showing risk, but there's been several videos going out that suggest that there's a shared sequence of amino acids in specifically the part of the mRNA that would take the viral spike protein and anchor it into the envelope of the virus. And that little piece of mRNA encodes a 4 amino acid sequence that anchors the spike protein into the virus. And that 4 amino acid sequence is actually shared with the syncytial protein on the trophoblast. However, this sequence is too short to stimulate an immune response. It doesn't bind to an MHC molecule, and it's too small to actually stimulate an antibody response. So while there could be a remote possibility of this happening, there's actually no evidence that it has ever happened. And the likelihood it happens because that amino acid sequence is so short is very, very, very small.
Okay. Dr. Evans, back to you on looking at people who say, well, if I just enhance my immune system and sleep well and eat right and do all the right things, maybe even take ivermectin preventatively, why should I get a vaccine?
Well, first of all, we have data on the effectiveness of these vaccines, and none of the regimens that you talked about can we say with certainty gives you 95% reduction of getting COVID. And especially if you are someone that has comorbidities or increased risk from getting COVID, you need that 95% assurance. But again, it is a personalized decision. But the important thing is that we're talking about biological plausibility, which is different than saying 95% risk reduction.
So I would acknowledge to everybody that the three of us, Dr. Evans, Dr. Carter, and myself, who are all seeing patients directly, all have chosen to receive the vaccine ourselves. But Dr. Carter, what do you do when you have a patient who comes in, expressing those concerns, both from the historical concerns relative to how they've been treated as experimental subjects, i.e. this vaccine is experimental at this point in time, even though we've seen it now in the clinical trials given to over 100,000 people, and in practice given to millions and millions of people. How do you counsel them? How do you listen to them? What's your approach with that?
My approach is to take the time to hear their story. I think it's very, very important. And I do not think it's appropriate to rush people to a decision. This is part of the reason I had concerned about some of the rollouts where certain communities were given 48 hours, for example, to respond whether they wanted to have the vaccine or not. I don't think that that's appropriate given this context. But I do think that every individual story requires listening and putting it into context. And then after I hear their story, I share mine. I share my personal experiences and the journey I took, that what I described in the talk is real. At first, I actually checked off the box that I wasn't going to get vaccinated yet. And then when I thought about the risk for me and the risk for those around me, I decided that 95% effectiveness of such a large trial was something I felt comfortable with compared to the unknown of getting COVID-19 infection.
Thank you. So people have asked me, what's really the goal of this vaccination program? And we see that the vaccines are useful to be able to decrease the development of symptoms of COVID, but we also see them decreasing hospitalizations and decreasing mortality. The data is there initially in smaller, what we'll call them smaller trials of 40,000 people, but we're seeing that data bearing itself out now in a place like Israel, where 40% of the population has already received the vaccine. Interestingly, the second highest vaccine rate in the world is in the United States. So while we wish it were faster, it's actually moving along pretty well. And we are seeing changes in the hospitalization, in the death rate, and in the overall infection rate that's going on. And this is not due to a decrease in testing that's there. I also think that one of the other big reasons for the vaccine program, from my perspective, is that I'm taking care of patients with post-COVID syndrome, some 12 or even 36 weeks out from being infected, who are still very seriously affected by the post-infectious sequelae of that. And working with them has led me to look at the data where 40% or more of the patients who've had moderate to severe COVID have long-term post-COVID, long hauler symptoms that go on. And so I feel like the vaccine is important. If we can decrease the degree of severity of illness through the vaccine, and we can decrease that post-COVID syndrome, that would be great. Now, that said, we don't yet have data on exactly does it do that. We're making inferences around that, and we're going to be clear about what we know and what we don't know with the data overall. So back to you, Dr. Zwicky. There have been questions about the mRNA. Both the mRNA vaccine that's given and how fast it degrades or sticks around, and then with the adenovirus vaccine, such as the one from Johnson & Johnson that I mentioned, where it's incorporated into the nucleus and then mRNA is produced. How long does it stick around, and how, is there a concern for the long-term presence of that messenger RNA?
Sure. Let's start with the mRNA vaccines. So with the mRNA vaccines, mRNA itself is unstable. And if you just have normal mRNA, it's usually going to be degraded very quickly, like within 20 minutes. The lipid that is going around the mRNA in these vaccines is providing protection, but is also helping it being taken up into cells. It doesn't go into germ cells, so it's not going into sperm or eggs. It actually doesn't really even go into muscle cells. It goes into macrophages in the tissue. And those macrophages now carry it off to the lymph node, where they're going to stimulate a T cell response, and they're going to be killed. We can see in the animal models that within 2 days, 48 hours, all of the mRNA is gone. So
even though it's synthetic, even though it is a modified or synthetic mRNA.
Absolutely, yeah. Even the modified mRNA is gone in 48 hours. So we're not worried about long-term consequences of mRNA sticking around in your body. It's a little different for the adenovirus vaccines. As you mentioned, the adenovirus vaccine is taken up, again, usually into macrophages and carried off to the lymph node. That's how we're going to stimulate an immune response. And then those cells are also going to be killed. However, because the adenovirus is a live viral vector, it may stick around as much as 7 days. It may, in some individuals who are immunocompromised or immunosuppressed or going through immunosenescence, stick around for as long as 3 weeks. And we know this from data that we have from the dengue trials, because this is a similar vaccine that we've used for dengue fever. It doesn't stick around for, well, the longest they've gone in 4 to 6 months. And it's not there at 6 months. It's probably not there at 12 weeks. It may be there for a week or two. But again, all of the cells that get infected are going to be killed. That's why it's a good stimulus of the immune response. If the immune system is doing its job, it's just going to go kill that adenovirus and any adenovirus infected cell.
Thank you. So, Dr. Evans, in addition to your work as an OBGYN, you've done a lot of work with cancer and worked and counseled and supported cancer patients through your practice for a long period of time. People are asking questions about, if I have cancer, does that mean I should be concerned about the role of getting a vaccine or not? And are there any relationships between the safety of vaccines in patients who have received cancer therapy? And of course, you can build into that, sort of the current recommendations around vaccinations as it relates to people who are actively receiving chemotherapy.
So it's interesting, Dr. Hanaway, because what you just described is what most people are concerned about, which is, if I have cancer, if I've just finished cancer treatment, is the vaccine somehow going to be problematic for having cancer and promote recurrence? The real interesting thing here is the real concern is that somebody undergoing cancer treatment will have a less effective response to the vaccine. So the issue here is that people with cancer and people undergoing chemotherapy or treatment for cancer are less likely to have an effective response. And therefore, most oncologists are recommending waiting until active treatment is completed. However, this again becomes a multifactorial decision about exposures and risks, et cetera. But there's really no concern about the vaccine making cancer worse. So people...
And then in the subset of patients who have finished active treatment, chemotherapy, the recommendations relative to any of the different kinds of vaccines, where do you sit?
I sit that it's a good thing. All my patients, as you said, I do have many patients that are involved in the cancer treatment process, and they're waiting, 3 months, 2 to 3 months after, post-treatment. However, for patients that are receiving monoclonal antibody treatment for their cancer, that's not a problem with lowering the effectiveness of the immune response.
Great. Thank you. Dr. Zwicky, there were many questions about autoimmune disease, and I'd just like to give you, sort of the closing time frame of a couple minutes here for you to speak about autoimmune disease and risk. And, we've talked about those patients who have uncontrolled autoimmune disease. Can you help to elaborate on that a little bit for our listeners? And I'm sure we'll have an opportunity to talk about that again next month.
Sure. So as you had in your chart so eloquently, if people have uncontrolled autoimmune disease, meaning they are not being controlled by medication, they're having frequent flares, the likelihood that vaccination could influence a flare can be very high. And when I say autoimmune disease, I'm talking about systemic autoimmune disease, talking about things like rheumatoid arthritis, lupus, multiple sclerosis. Why do we think that? Well, these vaccines in the preclinical trials and in the phase 1 and phase 2 trials have been shown to stimulate the production of interferon gamma. And interferon gamma can exacerbate autoimmune disease. We know that. So could this cause a flare? It could. For people who have controlled autoimmune disease, whether they're on something like methotrexate or they're on a biologic, the biologics will actually help control any flares that a vaccine might stimulate. So if your autoimmune disease is under control, we're less worried about vaccination. If the autoimmune disease is not under control, then we tend to worry. But let's also remember that rheumatologists have been saying for months now, in fact, almost a year now, that we're worried about COVID leading to long-term autoimmune disease. So if we're looking at relative risk of vaccination versus COVID, vaccination is much less likely to lead to autoimmune disease because we're looking at one protein, a spike protein, as opposed to an entire viral molecule. And we have quite a lot of data showing that infections using multiple different mechanisms can lead to autoimmune disease, molecular mimicry, bystander effect, etc. So what I want to make really clear is this is a might. This is dependent on somebody having T cells and B cells escaping central tolerance in the thymus and the bone marrow, getting into the periphery, having the right HLA background to have an autoimmune disease, and then getting stimulated at exactly the right time with the right peptide in order to lead to autoimmune disease. The likelihood is very, very small, but it's there. So I don't want to deny that it exists. But I also want to say that our likelihood of getting hit by a car on our way home is higher. Not that I want anyone to get hit by a car.
And to just, if you could also make a comment about the biologics that are currently used for a number of autoimmune diseases and what their relative risk factor is for those patients who are getting vaccinated.
Yeah, so I think one of the things that's interesting is that the biologics that are being used for autoimmune diseases are actually in clinical trials to be tested for COVID because they seem to help reduce the cytokine storm. So the biologics are perfectly safe to be administered with the vaccine. We're not worried about that at all. And in fact, the MS Society has a statement saying that for MS patients who are controlled, it should be safe for them to be vaccinated.
Thank you. I know there are many, many more questions, and we will have an opportunity to answer those questions in our next webinar, which will be on March the 16th. Appreciate that. If you go to the website and look at the information that we have on the dashboard that we put up, it will also contain the pre-vaccination protocol that Dr. Evans showed you, as well as you can find those things that will help with prevention and early treatment. So Dr. Luby, you want to take us home?
Thank you, Dr. Hanaway. Yes, indeed. We will be making this recording of the webinar available this Friday, February 15th. There will be further communication about that and how to sign up for the webinar on March 16th, which will be free. Please mark it on your calendars. Also, how to submit questions for that webinar. And as Dr. Hanaway mentioned, we will be updating the vaccine dashboard. So your questions about the vaccine formulations. Also, we will be having the author of a landmark article just published on how to improve your immune response to the vaccines. We will also provide you any evidence and outcomes that are emerging from chronic COVID or post-COVID syndrome as well, and any further developments on the pre-vaccination protocol that we've already developed. So we'd like to close with a special thanks to those of you who are new to functional medicine for joining us